Okay, this video is meant to help you understand how to graph in three-dimensional coordinate systems. And a three-dimensional graph looks like the one over here at the right. Basically, it's going to switch around your x and y axis a little bit. Instead of y traveling up and down, y is actually going to be the axis here traveling left and right, to the right being positive, much like the old x-axis. The new x-axis has sort of been spun so that it's supposed to look like it's coming off the screen at you. This line right here is your positive x-axis, and again, it's meant to look like it's coming toward you on the screen, whereas the line to the back here is actually meant to be traveling away from you, sort of through your screen out away from you. Okay? Now, one big thing to realize is when you're graphing in 3 dimensions, we're trying to graph with 3 different variables. And so occasionally we might want to change our equation to be written as a function of one of those variables. So often we'll say solve an equation so that you can write z as a function of both x and y, much like we normally write an equation for y as a function of x. We solve for y. So in order to solve for z, again, I'm going to take 3x and 2y. I'm going to subtract those over to the other side. And it looks like I forgot to remove the 2y. Don't worry about that. So we'll just kind of get rid of that here. All right, we've gotten rid of that 2y. So that the next thing to do is then divide away the 4. And now if you want to clean that up a little bit, basically what we can do is divide each of those parts. Or we can just leave it as is, but to be a function, we often take away that other variable, and we'll call that a function then of x and y. So if we name an x and a y, much like down below here, where x would be 2 and y would be 3, we can plug those in for x and y and find a solution. So that then we could plot the point 2, 3, 0 as an ordered triple. Now, those ordered triples will actually help us when we go to graph. An ordered triple where we could find the intercepts, like an x, a y, and a z intercept, would be helpful things to graph. Notice that intercepts, just as usual, would have zeros for everything except for what you're looking for, whether that be the x, the y, or the z intercept. So let's think about our equation over here at the left. If we made y into 0, then 2 times 0 becomes 0, it's just going to disappear. And the same thing goes, if z was 0, then 4 times 0 also disappears. And 3x equals 12, therefore divide by 3, x would become out equal to 4. We can do the same thing if we cover up x being 0, and z again still being 0, then divide by 2, and we would end up with y equals 6 for a y-intercept. And just the same way, cover up both x and y. If x and y were both 0, then 0 times 2 disappears. 0 times 3 added on, again, doesn't change anything. 4z equals 12, and z equals 3 is going to be my z-intercept. Then I can plot those points. I'm going to go ahead and say if x is 4, then I'm going to go 4 units, 1, 2, 3, 4, down the x-axis. I'm also going to travel 3 units up the z-axis, 1, 2, 3, and finally 6 units for the y-axis. So 1, 2, 3, 4, 5, and 6 units to the right on the y-axis. Then I want to realize that just like when we plot with intercepts in a two-dimensional world, basically the points that are between these points also count. So what I can do is draw myself a line connecting my points here to here. Same thing with the x and y, traveling through sort of the xy plane down here, this flat surface, sort of like the surface of your desk. And then also sort of like a back wall, the y and z axis make a flat surface, and there are a whole line of points connecting those points, those two intercepts, making sort of a triangle. If I fill in that triangle, I'm making a solid flat plane, and when you graph an equation in 3 dimensions, that's basically what you expect to have, is a flat plane full of points, technically extending outwards, but if we extended that plane out, we wouldn't see anything but just a huge blue surface. So we're only going to graph this triangle, creating that flat surface. Hopefully that makes sense. Again, use your 3 intercepts to create your flat surface, connect the dots and shade in, and it creates almost a flat sort of paper or sheet-like surface connecting those dots. go ahead, take a look at the equation here, see if you can find the three intercepts. Again, plugging in zeros for two variables at a time to create your three intercepts and graph that function. Go ahead and pause the video now, and you can try that out. Okay, hopefully you found if you cover up y and z, then x equals 4. Cover up x and z, then negative y equals 4, or y equals negative 4, if you divide by that negative 1. And again, if I cover up both y and x, 2z equals 4, divide by 2, I get 2. Plot those 3 points. Again, negative y, so I'm going left on the y-axis, but connect the dots and shade in the area. Now, another thing you can graph in 3 dimensions are just points. Rather than graphing whole surfaces, what if I want to graph an ordered triple? Now, to do that, we've got to sort of fake our minds out. We're trying to graph 3 dimensions in 2 dimensions. So we need to create sort of a box shape, kind of creating that forward dimension for that x-axis. So if I want to plot the point 6, negative 4, 5, what I'm going to do is draw a line forward on the x-axis 6 units. So you'll notice it ends right here at the end of this blue line. I'm also going to draw a line to the left, creating that negative 4 on the y-axis. But what I want to do is do both of those at once. So I'm going to create a line parallel to this line. Only now I'm going to travel 4 units down the y-axis, then forward 6 units on the x-axis. That parallel line creating sort of an equal measurement in that x direction. I'm going to do the same thing for the y-axis, taking that 4 units, again traveling forward 6, then left negative 4, and I'm so far have traveled in both x and y directions. Creating sort of a parallelogram, or in the xy surface, again sort of that surface of your desk, we haven't traveled up or down, it's creating sort of a rectangle in 3-dimensional space. I've gone left 4, I've gone forward 6, and I'm sitting here at this corner just waiting to travel either up or down. So now I need to travel 5 units in the z direction. So again, I've got the purple line creating a unit or a length 5 units upwards, but I need to travel that from this point, from my xy coordinate that I've already created. So what I'm going to do is create again that purple line, a copy of it, so of length 5 units, but I'm going to travel forward on the x, I'm going to travel left on the y, and my final coordinate is following the blue line, the red line, then the purple line. And if we put that point right at the top of the purple line, that's created the point then 6, negative 4, 5, right here where the black dot is. Let's go ahead and do that again with our point over here at the right. So negative 7, 3, 6. What I need to do is create 6 units down on the z-axis. So I'm going to grab a vertical line, I'm going to start at the origin, and I'm going to stretch that line to create it 6 units down, or ending at negative 6 on the z-axis. Then I'm also going to take my x direction, parallel to that x-axis. I'm going to create it 7 units, so I'm going to stretch that one a little bit as well, but 7 units on the x-axis. And then finally, I also need a measurement on the y-axis. So I'm going to move my red line here to create 3 units to the right on that y-axis. Now, what I need to do is not do those all separately. So I need to travel both 3 units right and 7 units backwards, right? Negative 7 on the x-axis. So I'm going to make a copy of my y-axis so that it's perfectly parallel and in the right measurement. Travel along that x. I went negative 7 units, then 3 units in the y direction. Or I could travel 3 units in the y direction, then negative 7 units. And again, I've got this corner point right here, having traveled in both the x and y directions. Then travel 6 units directly downwards, but again, from my previous point. So from that point, I'm going to travel 6 units directly down. And my final point, right at the end of that purple line, has now traveled in both the X, Y, and Z directions. That's my final coordinate. That's the point at -7, 3, -6. I hope that helps you understand how to create sort of that three-dimensional box. That X-axis, again, creates the forward motion. Y is left and right, and Z is up and down. If you have any questions, be sure to ask your teacher, and have a great day.